Good day, class. Welcome to our first lesson, Unit 1, the scientific method. Okay, so for today's lesson, we are going to be looking at a brief overview of the origin of the scientific method. What exactly is the scientific method, the various steps involved in this process of scientific investigation. We would look briefly at the importance of observation and measurement, differences between qualitative and quantitative data, and when each type would be appropriately used. And then we would look at a very brief example of how the scientific method is used. So what is the origin of inquiry? So we really start with the asking of questions, but where would those questions normally come from? Questions about anything, the environment, or in your case, you all would be particularly interested in the environment, phenomena, patterns, trends that you may observe in the environment can come through casual observation or your curiosity about a particular issue or phenomena. You may find that as you go about your daily life, to and from work, you may observe things either at your workplace or in the neighborhood where you live or on the route to and from those observations. When you couple that as well with exploratory studies and information rather, you actually position yourself in a very good place to ask very relevant and sensible questions. All right, so here I want to actually emphasize to you that when you begin trying to formulate questions to begin any kind of research, please understand you cannot do it in a vacuum. You cannot simply be determined that I am curious about such an issue and therefore you just sit and write a research question. It doesn't work like that. You need a little more information that requires you to actually study the issue, research the issue so that you can have a better understanding and grasp of the issue before you can sit and formulate a research question. Okay, so this is very important for you. We will talk about this in further detail when we meet for our live session. So we want to look at exactly what the scientific method is. So let's first look at a definition of it. So the method or the process of this method that has characterized natural sciences since the 17th century. It consists of systematic observation. So it must be well organized and strategic in your observations. The measurement of those observations or those variables that you want to measure, collecting data in order to facilitate that measurement, the development of an experiment. So the development of an experiment requires you to sit and think, okay, what data do I need? What methods do I need to collect it in the format and in the way in which I need to have that data in order to understand the data? How would I organize that data and manipulate the data in order to determine whether it proves my assumptions or hypothesis? We speak about hypothesis a little later on. Okay, so these are the things that are involved in the scientific method. It consists of systematic observations, measurements, an experiment, formulation and testing. So you're testing the data and you're testing your hypothesis to see if the things that you have observed or the data that you've collected, does it actually align with the assumption or the hypothesis that you have developed. So the primary goal of the use of the scientific method is to seek truth. All right, so just bear in mind that's what the goal is. However, as we will see, the scientific method is not perfect. As just about anything, nothing is perfect. Okay, so we have a summary here and we will look at each one in just a little bit more detail. So as I indicated, you start your investigation with a question. Again, note here, you have a dual way relationship between doing background research and a question, because what happens is you will start with an initial question in mind about a particular phenomena that's happening in your environment. But as you do your background research on the issue, you will find as you gain more knowledge, that knowledge and understanding will actually help you to direct the question in a more strategic way. All right, and this will be very important for us as we move forward in developing any research proposal, because oftentimes you realize that your ability to conduct the research might be limited based on resources that you have, based on the amount of time that you have. So you don't want to be asking questions that would be unrealistic for you to be able to actually answer in any experiment. So once you have determined the questions that you want to ask, those would be your research questions, you will then construct a hypothesis. So what is a hypothesis? This is a supposition, or in other words, an assumption or a proposed explanation that you make on the basis of limited evidence. So it's limited at this point because you haven't conducted any experiment at this point. So you're just making your assumption based on the research that you have done and any observations, initial observations you would have conducted. So you will construct the hypothesis statement. Then you will test. So this is a stage, test with an experiment. So you develop your experiment, as we said, your experiment development. This is where you develop in your methodology. Again, you make a determination, what data do I need to collect? How do I need to collect it? What instruments do I need to collect it? Over what period of time? How much data do I need? And once I've collected this data now, what do I need to do with this data in order to determine whether or not my hypothesis is true or false, right? So this is a huge area here. All right. Then you conduct your experiment once you've developed it. And then you have different things that can happen once you conduct your experiment, meaning you work with the data. I collect it and work with the data. Either one, you determine that it's working well and that you can proceed to the next stage to actually analyze the data and draw conclusions. If it is not working well, it means that you have to do a little redesigning here. All right, so if you run into problems and you realize, okay, certain things cannot be done, you need to go back and check your design. Okay, this is normally how it's done. And this is why we want to get this process done as much as possible in this semester, because in truth and in fact, this stage could be a little bit time consuming. All right, so so you'll have to repeat this stage, revisit this stage until you are able to proceed to the data analysis and conclusions stage. Then again, two things can happen. Your results can either align or not align with your hypothesis. So at the end of the day, you can draw conclusions as to whether your experiment supports or does not support your hypothesis. Okay. Again, notice if it turns out it does not support, you will have to revisit your hypothesis. Okay, so let's talk about this in a little more detail again. So you ask a question. So the scientific method starts when you ask a question about something. What is happening? How is it happening? When? Why? Where? Who is involved? So not every research question you ask would necessarily involve all of those. For example, if it's some kind of environmental testing, depending on the scope, if it's a narrow scope and you just say, for example, you're just doing water quality testing or maybe a soil test, it may not always involve a who, but then maybe it could involve a who. Maybe, for example, there may be evidence of pollution. So you may want to identify who are the possible contributors to that pollution. All right. The where, of course, you would always have to have geographic locations, particularly when it comes to environmental testing. Do your background research. As I said, you don't want to just pull research ideas out of thin air and then expect that you can automatically move to writing research questions and hypotheses. It doesn't work like that. All right. So rather than starting from scratch and putting together a plan for answering your question, use credible publications and internet research to help you find the best way to do things and ensure that you don't repeat mistakes of the past. This is what we don't want to do. You are not doing exploratory research at this stage. It is important for you to learn to understand and learn to master the application of the scientific method at this stage. So you are really trying to use a framework and apply that framework to a particular experiment that you will identify. So again, to start with a question that's of interest to you, as we said, something you're curious about, something that you may have made observations about, but always reinforce that with some background research so you can better understand the issue so that you can ask sensible, credible questions as you move forward. So the scientific method is essentially the application of the inductive reasoning method. All right, we have two types of research approaches. You can use a deductive approach or an inductive approach. The deductive approach, it starts with information. So you collect information. Then from that mass of information that you have, you will observe patterns. And from those patterns, you can make an assumption and create a hypothesis. And from that, you can develop a theory to say, all right, this is what is happening and that is why it's happening. All right. The inductive method of reasoning, which as I said, is the scientific method, is the opposite of that. If you look at it, it's essentially the pyramid flip upside down. So from here, we actually start with some data. That's what the definition says. You start with some data. So you start, and that data will help you develop a theory, or it might be an existing theory for that matter. So you're using an existing theory and you want to apply it to a particular environment. So that theory, you have a hypothesis that comes out of that theory. Based on your hypothesis, you will determine what you need to observe, what data do you need to collect, what variables do you need to collect. And from that data collection and analysis, you will confirm whether your hypothesis is correct or not. All right, so just bear in mind the approach that you all will be taking. The scientific method is actually inductive reasoning. So let's look at, again, in some detail, the steps in the scientific method. So assuming now that you have identified what you want to research, you have already identified and formulated your research questions, you now want to construct a hypothesis. So as we had previously indicated, a hypothesis is a supposition or a proposed explanation made on the basis of limited evidence as a starting point for your investigation. So notice, on the basis of evidence, limited though it may be, but is the basis of evidence. So you cannot construct a sensible hypothesis without doing some further research. All right. And again, I am emphasizing this to you guys because too many times students want to jump into identifying research ideas and constructing hypotheses without putting in the work. And when you when you do things the wrong way, when you put the cart before the horse, you will end up in trouble and you will take excessive amount of time in getting this thing done. So please follow the advice that is being presented before you and do it properly. Right. So the type of reasoning involved, as I said, is the inductive reasoning. Deriving a generalization from some specific details. For example, you collect the data and then you draw conclusions from that data. Right. So what does a good hypothesis look like? A good hypothesis allows you to then make a prediction. All right. So you're making the prediction before you conclude the experiment. So you're making a prediction up front, but not without information. So if we were to simplify it, we can say that a hypothesis statement will have two major components. And we can look at it like this. It will have an if component and a then component. So an if-then structure. Does not, please note though, stick up in here and pay attention. It does not mean that I am saying that the statement must have the words if and then in it. What I mean is the if part of the statement would usually reflect a particular condition. So in other words, if I do this or if these conditions exist, then this is what will happen. This is the result. So if these conditions exist, this is what will happen. So this is what I mean by if then. All right, let's go to the next slide. So we have a couple examples here to show you. So I would be expecting you all in your proposal document to develop a hypothesis with two versions of the hypothesis. I will expect an alternative hypothesis and a null hypothesis. So typically you present the null hypothesis first. This was a little bit flipped around, but typically you present the null hypothesis first, right? And the alternative after. So the null hypothesis is a hypothesis which the researcher tries to disprove, I beg your pardon, tries to disprove, reject, or nullify. All right. Whereas the alternative hypothesis is statement created by the researchers when they speculate upon the outcome. I beg your pardon, sorry about that. I keep touching something, right? When they speculate upon the outcome of the research. So this is what they expect the outcome to be. So most times if you develop a hypothesis and when you complete your experiment, you're oftentimes hoping that your results would allow you to conclude that you support the alternative. All right. But of course, if it is also valid research, if your results do not support the alternative, but they support the null instead. All right, but as we go along, you will see that it's not even so much an easy, straightforward thing to say, okay, yes, I'll accept the alternative and reject the null, or accept the null and reject the the alternative. It should be done in a scientific way, preferably using statistical methods, but we would look at that shortly again. So to give an example of these two types of hypothesis, you will observe that they are really two versions of the same issue. So if we look at, bearing in mind we just talked about the if-then components, this is a statement that we have. Notice alternative is H1. Tomato plants exhibit a higher rate of growth when planted in compost rather than soil. All right, let's break this down. Where is the if and where is the then? So what we're saying is the conditions is the if. So if we plant the tomato plant in compost instead of soil, so this is the condition, then we can expect the tomato plant to exhibit a higher rate of growth. So the if portion is actually the second part of the statement. The then portion is the first. All right. Now it doesn't have to be this way. You could have started off by saying when tomato plants are planted in compost rather than soil, or instead of soil, they will exhibit higher rate of growth. All right. It essentially means the same thing. It's just the way you structure the sentence, ensure that the two components are present. All right. So this is an example of the alternative. With the null, you will notice it's the reverse of the alternative. Tomato plants do not exhibit a higher rate of growth when planted in compost rather than soil. So again, the if part of the statement, when it's planted in compost rather than soil, and the then part, they do not exhibit a higher rate. All right, so here you have a nice simple example of how null and alternative hypothesis statements are presented. So again, you would be required to present both a null and alternative hypothesis statements. All right, so research questions followed by hypothesis. Okay, so continuing in the same on the same topic of the scientific method, we're going to just briefly touch on those independent and dependent variables. So an independent variable is part of the experiment that the scientist changes or manipulates to see what the effects occur. So notice this is applied, the variable is applied to the if part of the statement, right? So it's independent. In other words, nothing will affect it, but this actually can affect something else. So if we go back to the examples here, we said that the if part of the statement is a condition. So here we're saying plant the tomato plants in compost or soil. So this is where we can make the change. You either do soil or you do compost. And depending on which one you choose, you will expect that it will affect the rate of growth. So this is the one that will experience this will be the dependent variable, in other words, the rate of growth. All right. So there are two variables of interest here. Do you use soil or do you use compost? And then the other variable would be that you'd be measuring would be the rate of growth of the tomato plant. So the dependent variable, that's the part of the experiment that changes because of the change in the independent variable. In other words, the dependent variable is the effect that occurs from the changing independent variable, and this is your then part of the statement. So continuing, experiments are conducted on either control groups or an experimental group. So your control group, think about, for example, what they do in medical studies. They will have a control group, and then they will have the experimental group. The control group is essentially the group against which you are measuring the normal. This is normal. So they would give, let's say, like placebo medicine to that control group. And then the experimental group now, this is where they will change the variable and they will get the medicine. Okay, so you'll be measuring the response of the experimental group to that medicine against those who are not taking the medicine to see whether or not the medication is working. So in an environmental research context now, how does this work? You may find there are times you conduct an experiment where, for example, you may want to actually use two sample areas. One sample area or one sample variable may be considered your control group or your control data set because it represents the normal. And then the area of interest to you is your experimental group, well, in your case, it's not necessarily a group, but your experimental data or study area, this is where something has been changed and you want to see what the results of that data collection look like as compared to your control data set. So sometimes it may be necessary to design an experiment using a control data set. And in an environmental context, it could possibly be a different study area, maybe a pristine environment that is untouched by man, or maybe it may be another benchmark variable. For example, if you're talking about temperatures, you may be looking to find out what are the normal long-term temperatures for this particular area, and you want to assess compared to what is happening now. So these are some of the applications for this type of, for this, how to put it, this aspect of your experiment design. Right, so testing your hypothesis by conducting an experiment. So you have your experiment, you need to, sorry, you have your hypothesis, you need to carry out an experiment now. So your experiment tests whether your prediction is accurate and thus your hypothesis is supported or not. All right. So you design your experiment. As I said, your experiment design would involve things like determining what data you need to collect, how the best way to collect it, what instruments you use, how making a determination as to how you will organize and manipulate your data in order to make that determination. Note the second point there, you should also repeat your experiment several times to make sure that the first results weren't just an accident. All right. So when it comes to collecting data out in the field, it's also important to note here that in this case, the repetition of your experiments may be applicable to the collection of your data. So in other words, you need precision, and precision would be applied to the collection of your data from the perspective that you don't want to collect the data or collect the variable once. You want to repeat that a few times so that you make sure that you're getting the same or almost the same result each time. All right. Now, if you're using equipment out in the field, I know many times those pieces of equipment are already designed in such a way to collect your data in such a manner. But if it's a simpler instrument that you're using that may be manual, please note you collect it a few times, make sure you're getting the same result each time. All right, that would be very important. You want to analyze your data. So once you've collected the data, you want to analyze your data. So once the experiment is complete, you collect your measurements and then you analyze them to see if they support your hypothesis or not. Right? So this is where you would be applying statistical methods. So you all should have at this point completed STAT 120. So you all should have the basic understanding and skills of statistical analysis. So again, this is where you will have to apply some basic statistical analysis that would be relevant to your study. So the predictions, predictions and hypotheses are not always supported. Remember, I mentioned that already. Okay. So as such, the results of your experiment must be accurately communicated. So if you find at the end of your study that you cannot accept your hypothesis, you have to be able to clearly communicate in your report why this was so. So as I said, it is not wrong to come to a conclusion where you cannot support, where your experiment has not supported your hypothesis, but you need to be able to explain why. Okay. And last note, If it is not supported, the scientific method is started all over again. If supported, so in your case, you guys will not be required to do that, right? For a longer term, larger study, if it's not supported, normally the normal process is you revisit it and you redo and redesign your hypothesis and your experiment, etc. But you guys will not be required to do that, but you must be able to properly communicate why it is not supported. If it is supported, great. All right, that is what we hope for, but please note it does not always conclude like that. So in terms of the analysis, you would want to apply some kind of significance test. So this is where I said that you know, your knowledge and skills from your Stat 120 could be applied. So you want a significance test can be used to determine whether or not to support or reject your hypothesis. So these tests, they test the probability of obtaining your given set of results. All right. That is, it provides informed judgments regarding whether the null hypothesis is false or not false. All right, and notice here we focus on the null hypothesis typically. All right. I'm not telling you that your focus is to support or reject the null hypothesis only, because oftentimes it may lead to you accepting your alternative. All right. So we move forward, and then you draw your conclusions. So note here though, the scientific method does not always, it doesn't allow any hypothesis to be confidently proven. All right. Hypotheses can be proven, disproven, in which case hypothesis is rejected as false. All right. So I think I had a statement somewhere. Okay. So the point is about this weakness, that it cannot confidently prove your hypothesis. It really is a measure, especially if you're using significance tests. It's really just a measure of whether it is the likely outcome or not. Because remember, you are actually starting with the assumption, and your experiment will be designed according to that assumption. So it means then that certain elements may not have been included in your experiment. Certain variables may not have been included for sampling, which had they been included, they may have provided a different result. All right, but that's not what we are trying to do here. That is more exploratory research, and you guys are not doing exploratory research. Exploratory research is usually left to graduate studies, master's and PhD level. Okay, and so I don't want you all attempting to go in that direction at all, because you need to first master the application of the scientific method. Right, so communicating your results. So scientists publish their findings in scientific journals and books. They speak at national and international meetings, conferences, etc., and in seminars at colleges and universities. So these are some of the ways in which they communicate the results of their findings. But the whole point is, we're saying that dissemination of the results, this is an essential part of the scientific method, because you don't research something and then you leave the report to sit there. The report is intended to provide information, hopefully for decisions to be made about something. All right, not just to provide knowledge, but for decision making. So it allows for this communication of results allows other people to verify your results, develop new tests of your hypothesis. So maybe they may want to apply a similar thing in an area with a similar problem in order to and apply this knowledge that you have gained to solve other problems, right? So research doesn't take place in a vacuum. you want to be able to communicate that results for a purpose. All right. So, as we're talking about this, communicating your results for a purpose, it would also be good for you to consider when you're looking to identify or select a topic. Consider whether your research could provide data or information to solve a problem, right? You may not be in a position to actually solve the problem, but consider whether it is information that can solve a problem. Right, so now we want to talk about observations and measurements. So quantification of data is critical to the scientific method. We need to be able to measure things, quantify the variables that we keep talking about, the independent variable and the dependent variable. We need to be able to measure it. Those are our observations we need to measure. All right. So numbers must represent the quantity of the property associated with the concept. Quantification provides a standard of measurement. So that is how we standardize in things. You talk about comparing apples and oranges. How do you compare apples and oranges? You can't compare them unless you have a standard. And that standard, we may have decided, okay, we'll compare numbers. How many oranges in this basket? How many apples in this basket? Right? A basket of the same size container. How many oranges can one hold? So we're talking about standardization in that sense. And the reason we need that standardization is so that we can perform analyses on the variables that you have identified. So quantitative data, anything that can be expressed as a number or quantified. It can be expressed as ordinal data, in order, ranking, etc. Intervals, for example, some typical intervals would be like population groups, temperature intervals, things of that nature. Or then we also have our ratio scales, representing variations in magnitude. All right, these are just some examples of types of statistical data that can be measured. And it lends itself well to statistical manipulation. Qualitative data, on the other hand, cannot be expressed as a number. For example, some demographic information, such as gender, socioeconomic status, such as maybe various income groups, religious preference. Now, again, I want to stick up in here and just highlight to you though. Typically, that kind of information is not expressed as a number. However, you can also standardize that. That information can be converted into numeric data, for example, by adding codes. So for example, if you have gender, you have two genders, male, female, you can quantify that data. How many, for example, the Ministry of Health, when you look at the reports, they do that all the time with the COVID updates. How many male percentage, how many female percentage infections. If you do socioeconomic status, you might categorize the various status by income levels. All right. Religious preferences, you can apply numbers and quantify the data. So if you, for example, if it were a questionnaire survey that you had applied, you would actually be able to count each of those categories and actually convert the information into statistical data for analysis. So please don't think that you are completely limited by some types of qualitative data. Okay, so here we have a nice summary. I'm not going to go through everything in detail, but I'm just going to highlight the important points. So we can compare qualitative and quantitative research according to these parameters here. They each have a different purpose, approach, methods are different. the level of researcher involvement is in the outcome of the data is different. Sampling, the samples are often different, and the type of use. For example, purpose for qualitative, this is discovering ideas. When we use quantitative approach, and remember you are using the quantitative approach, is really for testing a hypothesis and specific questions. All right, so as I had mentioned before, the qualitative would be more exploratory in nature when there's a new phenomena you don't quite understand. So it's for discovering. The approach, qualitative, observe and interpret. So you're observing and interpret, whereas quantitative, you already have a specific question you're measuring and testing. Data collection methods, qualitative is unstructured and free, whereas quantitative, it is structured. All right, so if it's environmental sampling you're doing, you clearly know what parameters you're going out to collect. If it's a questionnaire survey, you will use a structured, oftentimes close-ended questionnaire survey. Researcher independence, qualitative, the researcher is often intimately involved. Sometimes they personally go and they conduct interviews and focus groups activities, often directing the questions and the again, as I said, it's very exploratory in nature, whereas the researcher for the quantitative is not intimately involved in the sense that you are not really determining the outcome of the results. All right, the results are more objective in nature. What you collect is what it is. And then last point here, qualitative, exploratory in nature, whereas the quantitative is descriptive and causal in nature. This because your purpose really is to describe and identify causes. Quantitative data collection methods versus qualitative. Again, I'm not going to go through all, but we just look at a few. Quantitative, as I mentioned, fixed and more structured. Qualitative, semi-structured or unstructured. All right. So again, let's just pause here for a moment. This does not mean because I say your research is inductive and therefore quantitative in nature. This does not mean that if you want to design your experiment to also include a qualitative element, that is also appropriate. So for example, you may have two parts to your research. You may have a quantitative data collection sampling method. You may also at times find it prudent, okay, well, I need to conduct a few interviews with technical experts on the issues. So in that case, you may find that a semi-structured interview may be appropriate. All right. Quantitative data collection, you will use instruments, not only scientific instruments, you will use questionnaire survey instruments as well. No instruments are used for qualitative. It's quantitative is numbers based, whereas qualitative is text based. Quantitative is measurable, qualitative is not measurable. Quantitative, you have a large sample size, whereas qualitative, this would be a small sample size. So for example, if you have a qualitative aspect of your research and you need to do actual interviews, you are not going to interview 100 people or 50 people. You may interview maybe anywhere from 3 to 5 technical experts. So that would be a small sample size, okay? So I just want you all to take some time and go through these tables, make sure you understand the differences. Okay, and as mentioned before, the scientific method has limitations. So we see where we can have personal and cultural beliefs that influence both our perception and our interpretation of natural phenomena. So even our world view of things can affect the way in which we perceive natural phenomena. All right. And that perception now can cause us to develop false hypotheses from the beginning. And if we have a false hypothesis, that can survive the testing process, and then you end up accepting the results as correct. And in other words, concluding that this is the way the world works. For example, observations that should not have been collected and tested were not, sorry, I beg your pardon, let me restate that. Observations that should have been collected and tested were not even identified. Okay, so you will have very skewed results because variables that should have been included were not even identified and included in the experiment. All right, so to draw all of this together, pull it all together, let us conclude with a brief scenario of the scientific method. You all may be familiar with this scenario, but now what we want to do is we want to apply the scientific method to it. So our scenario begins. There was an outbreak of cholera in Soho in London in 1854. It was not known how cholera spread or that it was due to dirty water. A doctor named John Snow used the scientific method to try and stop the cholera. He plotted all the cholera outbreaks on a map of London. He then made some observations and proposed a hypothesis which he tested. So let's break down this scenario. So he had a first and second observation. Let's look at each. First observation, he noticed that most of the cholera outbreaks were near the water pump on Broad Street. So he was able to determine that from his map. He also observed that the cholera affected the digestive tract of victims. Okay, so that would have been from interviews. The second observation he made, he interviewed people who lived on the street from the data that he collected and discovered that all the cholera victims had drunk from the pump. So he's now able to make that connection between the victims and the pump. He also discovered that visitors to Broad Street who had drunk from the pump died. So persons from outside now who drank from the pump died. So, and persons nearby who drank beer instead of water did not get cholera. So based on all the observations that he was able to make, he was able to formulate a hypothesis where he suggested that the cholera was picked up from the water pump on Broad Street. Now, in order to determine if his hypothesis was correct, he had to carry out an experiment. What did he do? He blocked off the pump by removing its handle. So he blocked it off now. So this is the independent variable that we're changing here. All right, so if the pump was blocked off, then what will happen? The result was the then part of the statement, the epidemic died out. So this hypothesis was taken to be correct. It was applied to similar outbreaks of cholera around the world and saved many of lives. Okay, so in conclusion, guys, this was a brief summary of the scientific method. I hope that it helps put some things in context for you, and we will speak a little bit later and answer some of your questions regarding topic selection and the preparation of your proposal document. Thank you.